Okay, so this is, I'm going to solve number 52 here, okay? So let's see, where's the, no, it doesn't, oh, here. All right, sorry guys, I'm just trying this stuff out. Okay, so number 52 says that Maggie is pulling a sled with a force of 275 newtons by holding its rope at a 58-degree angle. Her brother is going to help by pushing the sled with a force of 320 newtons. So this is Maggie's force, and it's got a magnitude of 275 newtons and an angle of 58 degrees. The brother is going to push horizontally, so this is the brother's force here. All right, so what I'm going to do is I'm going to call this vector M and call this vector B. The brother is pushing horizontally with a force of 320 newtons. So actually that arrow technically is a little bit bigger than the one for the 275. Now it says, determine the magnitude and direction of the total resultant force on the sled. So this is 320 newtons. Well, this is exactly the same as what we were doing on the worksheet in the beginning, and then we're just going to have to add them. So we have two vectors here. Let me make this a little bit bigger. We have two vectors here. We're going to add these vectors, and we're going to find the resultant. Okay? Now, we have vector M, right? And we have vector B. All right, so let's write down the components of M, and then we'll write down the components of B. M has an angle, okay? So if you look at the components of it, let me get another color. We have the Y component and the X component. And now look, the X component is this. It's the side that's adjacent to the angle, so that's the cosine, right? So it's always magnitude, cosine, angle. So it's the magnitude times the cosine of 58. That's the X component. Now the Y component is this one. The Y component is the opposite sign. It's the opposite side, so it's sine. So it's 275 sine of 58. Now, direction. The Y component is pointing up, so it's positive. The X component is pointing to the left, right? So it's negative. Okay, because how do you get from there to there, from the first to the end point? You have to go left a little bit. So this is negative. So that's the vector M in component form. All right, what about vector B? Which direction is vector B pointing? It's just pointing left. Does it have any vertical component? No vertical component. It's all in the horizontal component. So we just say, okay, this is negative 320, comma, 0. Okay, so that's vector M and B in component form. Now what I want to do is I want to find the resultant. So technically, how do we find resultant? This was Maggie's force M with a degree of 58 degrees. And this is my second vector, right? How do I add vectors? I'm going to get my second vector B and add it to this as a continuation of M. Do you see how that works? This is what you were doing on the worksheet. So the resultant vector is this one. Okay? That's your resultant vector, M plus B. All right? What we're gonna do now is mathematically find the magnitude and the direction. So before on the worksheet, you were measuring this with a ruler for the magnitude, measuring with a protractor to find the direction. You're not going to do that anymore. Okay? All right, so first what we're going to do is this. Let's get the, let's simplify this. So how much are these components? So we have negative 275 cosine of 58. How much is that? Anybody? We have to be in degrees. So it's negative 145.7. And the other one is the sine of 58. So it's 233.2. Okay, now m plus b in vector form is just the sum of these two. So I add 145.7 plus 320
minus 465.7.
Negative 465.7. And this is just 233.2. So that's that component, that resultant in component form. Now the magnitude is the distance formula. So it's negative 465.7 squared plus 233.2 squared. Okay, so you put that in and what do you get? Anybody? So it's 520.8 newtons. So that's the magnitude. Now what do we do for the direction? How do we find direction?
You take inverse tangent.
Right. Tangent of theta is y over x. So tangent of theta is 233.2 over negative 465.7. And theta is the inverse tangent of all of that. Okay? And now, so what does that give you? 53.3 degrees, you're sure? Oh, whoops, not there. But does that make sense? Okay? All right, so what quadrant is our vector in? What quadrant is it pointing in?
I got negative 26.
That makes more sense. That makes more sense. I thought you did it now.
Yeah, we you have to add 180.
No, okay, so hang on. So
yeah,
that's not the, okay, so, Danielle, what did you get?
I got negative 26.6.
Okay, now, this vector, though, is pointing in the red vector is pointing in the second quadrant, right? So that means your value has to be somewhere between 90 and 180, right? So if you have a reference angle of, 26.6, let's say, what is the equivalent of that here? Okay? Yeah, so basically, this is your vector. This is 26.6, okay? And what you want is that angle, okay? So it's 180 minus this one. This is the one that you want. Huh? Oh, here, I'm writing here. Here, no, sorry, here.
Oh.
Okay? So that's the angle that you want, okay? So for that, it's going to be 180 minus 26.6, which is what? Right. Okay, that's the answer. So that's the direction. Okay? are we all on the same page?
Yes, but I think if you use like one more.
Okay. So I'll set up 53 very quickly. So 53 says, you have an airplane traveling due east with a speed of 600 miles an hour. So this guy is traveling that way, 600 miles an hour. The wind blows at 85 miles per hour at an angle. So the angle is S 59 east. Okay, that means it's 59 degrees east of south. Okay, so if this is your south line, then it's 59 degrees east, so that direction. Okay, now that vector is going to be added to this. If you want to draw, close to scale, it's 85, so it's considerably shorter than the first one, like that. Okay, so this is 85 miles per hour. That's the speed of the wind and direction of the wind. And this angle here is 59. Okay? All right, so what we're going to do is we're going to call the first one vector A, and I'll call this one vector W. So what are the components of vector A? It's all in the x direction, so 600, and nothing in the y direction, 0. Vector W, okay, now, in the x component, this is the x component here, all right? Now, it doesn't matter whether it's vertical or horizontal, right? So the x component is the one opposite from the angle. So is it going to be sine or cosine? Sine. So this is 85 sine 59. And then the horizontal component, this y component is 85 cosine 59. Okay? Do you guys see what is going on? All right. So now the resultant A plus W is 600. So you add this. So 600 plus 85. This one is. So it's 672.9. Comma, what's 85 cosine of 59? And notice for this wind vector, both y and x, is y pointing in the positive or the negative direction for the wind vector? Y is pointing in the negative direction, so there should be a negative here. All right? Here, y points downward. Okay? So now, the magnitude is going to be the square root of 672.9 squared plus 43.8 squared. And the direction, theta, is inverse tangent of negative 43.8 and 672.9. Okay? Your vector is pointing, your resultant vector is this. It's pointing towards quadrant 4. So make sure that your angle value is an angle value for quadrant 4. So somewhere between 270 and 360. All right?
I know it's not relevant because you're squaring it. The 43.8 is negative.
I know. I just let it, yeah, I let it out because of the, okay. Yes, the magnitude of the airplane's velocity is now 674. So even though the pilot has set the airplane to fly at 600 miles an hour, the wind is pushing it and it's making it faster, 674. So that's why, like when you fly to the East Coast and when you fly back, there's always like an hour difference. It's faster flying to the East Coast because you're going with the wind.
That's the magnitude.
whereas the other direction is against the wind.
In the poem itself, what does it ask for?
Both magnitude and direction. Yes.
And magnitude, you put MPH, right?
Miles per hour. Yes. Okay. Now, section 3 then.
Welcome back.
All right, so 8.3, dot products and vector projections. Okay. All right, so look at this scenario for a minute. What we have are two vectors, a vector A and a vector B. Okay. Now, suppose you have a flashlight and you hold the flashlight here. That's my version of a flashlight. I don't know how to draw a flashlight. Okay. You shine the flashlight like that and it's like straight down. Okay. When you shine a flashlight, let me actually. When you shine a light on this, you will see a shadow of A onto B, right? You will see a shadow of A on B. Is that true?
Yes.
Okay. Now, that shadow, okay, so this is the shadow. We don't call it a shadow in math. We call it the projection of A onto B. So it's just like saying it's the shadow of A on B, but it's the projection of A on to B. Okay? Now, the product of the length or the magnitude of this projection and the magnitude of B is called the dot product. So let me say that one more time. You shine a light on A and it casts a shadow on B. Okay, now you measure the length of the shadow. You measure the length of B. For fun, you multiply them by each other, and that's the dot product. Okay, so what is the dot product? It is the product of the projection of A onto B times B. Okay, so that's what it is.
You use the dot product to go back and find B.
Yeah. Okay. So now, so the length of the shadow okay, times the length of B equals the dot product. All right? Now, is magnitude a vector or a scalar quantity?
Alone.
Yeah. Magnitude is scalar. So if you're multiplying the magnitude of the projection, so that's a scalar. What about the magnitude of B? Is that scalar? Yes. So the dot product is also a scalar.
Is there no like identity scalar squared equals
No.
vector?
Okay? All right. So here's, if you have the vectors in component form, here's how you find the dot product. So if vector A has components A1 and A2, and vector B has components B1 and B2, then A dot B, that's how we write dot product, okay, is A1 B1 plus A2 B2, okay? So it's A dot B. That's the dot product. Okay? Huh? I know. It's literally a dot.
Can I make it like a really large dot? So I don't confuse it with the other stuff. Like that?
Oh my. That's not a dot. That's a polka dot.
still like a variation of dots.
Okay.
You ran out.
So, all right, so, how are we gonna find the dot product here?
Then you get that BA is equal to the square root of A squared plus B squared.
Okay, what happened here? So what's the length of BA?
Square root of A1 plus B1.
Okay, so let's do this. Where did we go? Okay, so the length of BA, okay, is, now I want the distance formula, right? Oh, that's what you meant. Okay, so the length of BA is, okay, so we're going to apply the distance formula, right? So it's going to be A1 minus B1 squared plus A2 minus B2 squared. Now, I don't like that square root, so let's just square both sides of this. And you get A1 minus B1 squared plus A2 minus B2 squared. Okay? And since we came this far, why don't we FOIL this? So we get A1 squared minus 2A1 B1 plus B1 squared plus A2 squared minus 2A2 B2 plus B2 squared. Yeah?
Yes.
Yes?
Does that say B1 plus B1 squared? Why not?
Oh, can you factor?
No. Okay, now, what do we have here? Let's just regroup things, because we like doing that. A1 squared plus A2 squared, I'm just going to write it here. Okay? And plus B1 squared plus B2 squared, right? Plus, what else do I have?
Minus 2 A1 B1 minus 2 A2 B2. So this is when people talk about when they say we lose numbers in math.
Uh-huh. Okay. Now. Yeah. We're okay? Why? I just rearranged. So I wrote A1 and A2 together and B1 and B2 together, and I'm just combining like terms.
Let's take the square root of it.
Okay.
Bring us back to
Now look, if A is a vector and its components are A1 and A2, right? What's the magnitude of A? What's the magnitude of A? It's A1 squared plus A2 squared, right? So if you square that, what do you get? A1 squared plus A2 squared.
Oh, so that is.
So this is just, oh my goodness, is just the magnitude of A squared. Okay, plus this then is the magnitude of B squared. Plus we've got some other stuff. Okay, now, is this a right triangle here?
Yes.
So if you wanted to use the Pythagorean theorem on this, what would it be? The magnitude of A squared plus the magnitude of B squared would give you the magnitude of BA squared,
Oh my God,
right?
that's actually so cool.
So now, this is the Pythagorean theorem, except You've got all that junk over there, okay? So what you have really is this. So BA squared is equal to A squared plus B squared minus 2A1B1 plus 2A2B2. So this could totally be the Pythagorean theorem if this little bit equaled 0. Okay? If only that was 0. Okay? Well, what is that part? That part is the dot product. Okay? So this is where the dot product comes from. All right, so now to further appreciate this, look at this. If you shine a light, okay, on vector A, this way, all right, if you shine a light on vector A that way, if A and B are totally perpendicular, would there be any shadow on B? If A and B were perpendicular, and if you were shining a light this way, there would be no shadow. And if there is no shadow, the dot product is 0, okay? That means you can apply the Pythagorean theorem.
So that's why in your right triangle you can just make that 0.
Right.
Wait, no shadow meaning that like it would just like fall off the line.
Yeah. It'll be like perpendicular. So, you know, if I've got this and this, yeah. Well, if I were shining a light on this, it wouldn't make a shadow because it's just concentrated on a point. Okay? So that's the dot product. Okay, that's where the dot product comes from. Yeah. All right? Okay. That is really amazing. So that brings us to orthogonal vectors. What's orthogonal? When you go to the orthodontist, what do they do to you? The orthodontist, what does the orthodontist do? Why? Why? What does the orthodontist do to your teeth? It makes them what? It makes them straight. It makes them straight. The orthodontist makes your teeth straight. So if you have orthogonal vectors, they're perpendicular. You have straight lines. Okay? Thank God for those Greeks. So orthogonal vectors are perpendicular vectors. So if an angle between two vectors is 90 degrees, then if you were to shine a light on this, it would cast no shadow onto the ground, onto B. So if the sun was directly above you and it was shining on you, there would be no shadow of you on the ground, right? There's only a shadow if there is an angle other than 90 degrees. So that just means that if you're dealing with orthogonal vectors, then A dot B is 0. Also, if you do A dot B and you get 0, that means you have two orthogonal vectors. No more perpendicular, it's now orthogonal. It's the same thing with the orthopedics, right? So it makes you straight, okay? All right, so let's do some dot products here. All right, find the dot product of U and V. So we say U dot V, all right? It's going to be, oops, no more components. Negative 3 times 3 plus 4 times 6. All right? You multiply the first ones and you multiply the last ones and you add them. It's like if you had a row matrix and a column matrix. Okay?
Wow!
Yes, yes. Negative 9 plus 24. So what's U dot V?
15.
Okay? Here, U dot V is 2 times negative 14 plus 7 times 4, negative 28 plus 28. U dot V is 0, so these two are orthogonal. Meaning if you draw vector U, if you draw vector V, and if you were precise about it on graph paper, and if you took your protractor, which you all have now, and if you measure the angle in between, what would you get?
Oh, 90.
90. 90.
You wouldn't guess one.
So now, what if, Okay, so what if you have a vector v, okay, or a rather, and you clone that vector a, that's not cloning at all. You clone that vector a, and now you shine a light. How much of vector a's shadow will fall on vector a?
100%.
The entire thing. Why does this not go away? Why does this not go away? All right. So the entire thing, meaning the length, so what's the dot product? The dot product is the length of A times the length of the shadow, which is still the length of A. So A dot A is A squared, right? And what's A squared? It's the square root of A dot A times A, okay? Yes. So use the dot product to find the magnitude of this one. So how are we going to find the magnitude? Go ahead and find the magnitude. And people at home watching can find the magnitude. So,
How's your day, man? You guys having a good time watching screencasts?
so basically,
Subscribe down below.
the magnitude of A is just A dot A. Okay? So it's like if we were doing -6 times -6 plus 5 times 5. So it's -6 squared plus 5 squared. And the magnitude of A is 36 plus 25, the square root of 51.
If you had two perfect squares, then we just had to
I know.
get rid of any perfect squares.
All right, so what about the angle between two vectors? All right, so we can use, we can get a more concrete definition of the dot product using this diagram, right? Okay, so what is the dot product really? The dot product, okay, is the magnitude of B times the magnitude of what? Times the magnitude of the projection of A. Okay? All right. So, what is the magnitude of the projection? So this is the projection, okay? So it's like this is a component of vector A, isn't it? Right? In fact, this is the component that's adjacent to theta. So how big is this? It's the cosine. So this is just A cosine theta. So A dot B, okay, if it's the magnitude of the projection, then that's just A's magnitude, cosine theta, times what's the magnitude of B? Well, that's the magnitude of B. Okay? Well, cleaning that up, A dot B is really A times magnitude of B, cosine of theta. Okay? Now, what if we have all of that, but we don't have our theta? All right, well, can we solve this for cosine of theta? We sure can. Cosine of theta is A dot B over magnitude of A, magnitude of B. Okay, and it's very elegantly presented to you here. Okay, so if you have vector A, and if you have vector B, and you know the angle in the middle, or you want to find the angle in the middle, then it's just A dot B over their magnitudes. All right? Say yes.
Yes.
All right, okay. So go ahead and let's find the angle between vectors U and V. So what we want first is U dot V. Let's find that first. U dot V is 1 times 2. I keep doing the component. So 1 times 2 plus negative 4 times 6. This is negative 22. I also need magnitude of U, and I need magnitude of V. So how do I find magnitude of U? It's the square root of 1 squared plus 4 squared, root 17. And this is the square root of 2 squared plus 6 squared, root 40, which is what these days? 2 root 10? So now we need the angle. Well, cosine of theta is U dot V over the magnitude of U, the magnitude of V. So cosine of theta is U dot V is negative 22 times root 17 times 2 root 10. So really this is negative 11 over root 170. And we take the inverse cosine of this. So what's theta? Somebody, anybody? That's the one.
You cancel out with the 11.
Sarah got the right value, so everything else must be right there. Okay? All right, how are we doing here? All right. Okay. So, yes. Okay, so recall, right? So remember what we did before. We had come up with this formula, right? Projection of A is A dot B over B. Yes? Yes, yes? Come on.
Yes.
All right. So this is only the magnitude of the projection. Remember, we got a scalar, and we just got the magnitude. We had said A dot B, right? What did we say before? We said A dot B is B times the projection. And this is only magnitude. Well, we need to give it some direction because, yeah, we have to give it a direction. But, okay, so its direction, because it's a shadow cast on B, it's got the same direction as B. All right, so it's flying at the same angle as B. All right, so how do we give a magnitude, something that's just a magnitude, the direction that we want? Well, we multiply it by a unit vector that goes in the direction that we want. That's the point of why we found unit vectors.
Wait, so you can turn a scalar
Into a vector.
You can't turn a vector into a scalar.
Well, you can find the right, I guess so. Yes, yes. So you can take a scalar number, multiply it by a unit vector, and it now has some direction. Okay? So if we wanted to have the same direction as B, then we have to multiply it by the unit vector of B. Okay? So what was the expression for the projection? The projection was this. That's the formula for the projection. Now I have to multiply it by the unit vector for B, which is the vector over the magnitude. And if I put those two together, this one in the circle and that one in the circle, see, if I put them together, then what do I have here? I have A dot B over B squared times vector B. So if I were to write that, it's A dot B, yes, over the magnitude times vector B. That now is the projection. Squared. Yes, squared. Absolutely. Okay, so now let's find the projection. Oh my God, I love this stuff. Okay, so let's find the projection. Okay? Like, I could do this all day.
I mean, you do it.
I do it all day. I do. That's what I love about teaching, is I can get paid for doing this all day. Okay. So what we're going to do first is we want to find A dot B. So U dot V. And that's just -4 plus 30. So U dot V is 26. Now, I want to find the magnitude of B squared. Okay? So now look. Watch what I do here for a minute. The magnitude of B is the square root of, right? Well, this is V actually. It's the square root of 4 squared plus 6 squared. But since I want the square of this, then, you know, technically that square root will make itself go away. So V squared is 16 plus 36, 52. Okay? And now what we're going to do is we're going to find the projection of A onto B. So that's going to be A dot B, 26, over the magnitude squared, 52, times vector V, 4, 6. So this is 1/2, 4, 6. So this is 2, 3. That's the projection. Okay? All right. Now, write U. So now it says write U as the sum of two orthogonal vectors, one of which is the projection of U onto V. Okay, what does that mean? Okay, so I'm going to call this vector W. Okay, and now it says write U as the sum of two orthogonal vectors, one of which is the projection of U onto V. So we're going to make this U equal to W plus some new vector Q. Okay, I'm just going to call it Q because I don't know what else to call it. Okay? All right, well, we have U, right? What is U? It's -1, 5. So wait a minute, let me just solve this one. That means Q is really U minus W. Is that right? Okay. So vector Q is vector U minus vector W. So vector Q is -1, 5. -1 minus 2 is -3. 5 minus 3 is 2. Where am I getting these numbers from? U is this U. And W is this W that I just found. Yes. Okay? All right. That's fine. We're fine here. So, homework will be due Tuesday. Okay? You also have a quiz on Tuesday. And actually, after the quiz on Tuesday, I'm going to show you something like spectacular about this problem here. All right? And you will be amazed. And then we'll review after. All right? Cool. All right. See you guys.